All right, operations on functions. First of all, let's remind ourselves how to evaluate a function. Function notation says f of x equals 2x plus 5, for example, and we want to find f of 3. What that tells us is that we're going to put this 3 in place of all the x's. So this 3 here is going to go in place of x. So we would say that we would have 2 times 3 plus 5. 2 times 3 is 6, plus 5 is 11. Okay. Alright, here are two functions, and we're going to do f plus g of x. That could be written as you see here. This could also be written as, you might see it written this way as well. Okay, and all it means is that you're going to take the f plus g. And so what you're going to do is write down the first function, so f, so x squared plus 4 plus g of x. And then you're going to simplify as possible. So you combine like terms. And so this would be f plus g of x. We can do subtraction, multiplication. Let's do a couple of those. All right, f minus g of x. So we write down f first. Minus g of x. We want to minus all of g of x. So you notice that I'll put that in parentheses. And then we want to simplify. Okay. So there's understood to be a little 1 right here that we're going to distribute through the parenthesis. Combine like terms. So here is f minus g of x. Multiplication, f times g of x. So we write down f times g of x. And you'll notice this, for this one we're going to have to multiply these together using FOIL, or you could use the box method depending on how you would prefer to do it. I'm going to do both ways. So if you like the FOIL method, first times first. So there's the f. Outside. Inside. And then last times last. And then combine any like terms if possible. There are no like terms, so this would be it. If you get lost in these arches that we're drawing, you could also do what I call the box method. What you can do, let me get a different color here, is you can write x squared plus 4. This works for only multiplication if you do polynomials. And so what you do is you create a box. So it's kind of like the area model. So it's like length times width for this box would be x times x squared. So that gives us x cubed. And then for this box, x times 4, well that's 4x. 3 times x squared. And then 3 times 4. And you'll notice you get exactly the same thing. It's just a little bit more, it's a little easier to organize is all. And then of course you want to combine any terms, like terms if possible. This one doesn't have any. Composition of function, it looks like fog, or if I had it backwards it would look like golf. So what this tells us is that we're going to put g of x inside of f of x. So it's going to be kind of like this. So we're going to put all of g of x into f of x. So it would look like such. So I'm going to attempt here. Here's what f of x looks like without the x in there. We're going to put all of this inside. And then of course we want to simplify that. So you have x plus 3 quantities squared plus 4. So this really means x plus 3 times x plus 3. So again, you can FOIL or you can use the box. I'm going to come over here and do the box. It helps me stay organized is all. Forgot my plus sign. So x times x, x squared, x times 3, 3x, 3 times x, 3x, 3 times 3, 9. Combine any like terms. These diagonal ones are alike. Combine anything else. Well, the 9 and the 4 will go together. So this will leave us with x squared plus 6x plus 13. So this is composition. All right, for good measure, let's look at g of f of x. So what this means is that we're going to put f of x inside of g. So I'm going to write down g with a hole in it, essentially. Right? So I left a hole where x was. I'm going to put all of f of x inside g. And combine any like terms if possible. So this would be x squared plus 7. Alright, so now I've changed the two functions. And this time you'll notice that I have a 3 where the x was to find f of g of 3. So here's how this works. We're going to put, you kind of go start from right to left in doing this. So we're going to put 3 inside of g to start out with. So we're just going to find g of 3, okay? So g of 3 is 9. So now we're going to put 9 inside of f. Okay, so again, you kind of go backwards. You put 3 into g, so that's step 1. And then you're going to put all, whatever that answer is, you're going to put it into the very last, furthest left function.